All right, guys, I want to share this animation or simulation with you. I can't use the school computers to show this one due to the conflict between Google and Adobe Flash. So this simulation hasn't quite made it over to the Cheer PJ versions of the FET simulation labs either. Not yet. But here we go. You've got a 9-volt battery down here at the bottom with a 20 ohm light bulb, okay, which is all connected to a capacitor of 0.2 farads. And there's a switch over here. Right now, notice the little blue spheres, which represent electrons, aren't moving because the switch is open. When we close the switch, pay attention to what happens. We've got a measuring device following the current in the circuit here. Because the electrons are not moving, the current is at 0 currently. But look what happens when we close the switch. Pay attention to the current and also pay attention to the capacitor. Electrons are now moving. The capacitor is getting charged up. But now notice what's happening to the current. The electrons are moving slower and slower and slower as the charge is now built up to its near full potential on the capacitor. And there's air between them. Air is not a very good conductor. So the charge is now stuck on the capacitor. And there's no more current flowing through. The current is approaching 0 now. It has approached 0. So there's no more current. This is a useless circuit right now. But charge is still stored on this battery. Or I shouldn't say battery, I should say charge stored on the capacitor. If I close the circuit and I allow the capacitor to discharge, watch what happens to the light bulb. The light bulb works, and then as the capacitor charges itself up again, now it's not working anymore. So again, let's open up the switch. If I open the switch and discharge the capacitor, nothing's going to happen to the light bulb because it's not a full circuit. Okay, so we're back to current is 0. Notice here how there is some time for the capacitor to get fully charged. So when we close this circuit, watch the light bulb. Watch what happens to the light bulb as we close the circuit. Light bulb is working, but it's becoming dimmer and dimmer and dimmer and eventually shutting off as the capacitor charges up. And if we want to discharge the capacitor, probably one of the more classic examples of what a capacitor is used for is a flash in flash photography. You press a button, you discharge the capacitor, you send the flash off, and then it goes away. The light turns off as the capacitor charges up again. Now I've set this up to be 20 ohms, and I've set this up to be a very high capacitance, so things would happen slowly. Usually happens much faster than this, but you can hopefully get the idea. Again, you could press a button on your camera, set the flash, the light bulb would turn off, the capacitor would be then charged for the next time it was next time it was wanted to work. Open the switch, no more current flows. Pretty simple. But again, the key thing here is the time that it takes for the capacitor to charge up. A capacitor is simply a device that stores charge, and it's good for like a temporary battery. It doesn't offer a continuous flow like a typical series of cells in a battery. It's just a momentarily flow of charge.